Now, one thing you may remember about significant figures is that there are rules regarding significant figures when we're doing calculations with them. We'll cover addition and subtraction in multiplication and division. Specifically, in this class, there are additional rules. And by the end of this chapter, we'll get to the more fundamental rules regarding propagation of uncertainty in general, which is where these Sig Fig rules really come from in the first place. But let's look at addition and subtraction and see if you remember these rules. And whenever you're working with significant figures in this class, you'll need to keep track of these rules. Don't give me a number that has just however many digits your calculator spit out. You'll need to think about how many significant figures are the appropriate numbers of significant figures for the calculation you did. Okay, so the rule for addition and subtraction is that the number of Sig Figs, or I should say the number of decimal places, not Sig Figs in this case, number of decimal places in the answer is the same, not same as the least number of decimal places in the values. What this reflects is that when we add and subtract numbers together, the scale of the numbers matters. Okay, let's look at an example here. We have, say, 1.025 plus 1.15. Okay, we can add these together manually here. All right, so I have a 5, 7, so, sorry, 2.175 is our answer. But this number here has the least decimal places. So we need to round our final value to that same number of decimal places. So we'll round this to 2.18. And that's our final answer. We'll have 2 decimal places, just like 1.15 here only had 2 decimal places. Now this can get very extreme. Say we're adding together the numbers 254.2 plus 0.0007568. Right, so these both have 4 significant figures, but one of them is much, much more precise than the other. Right, so this has, 1, 2, 3, 4, 5, 6, 7 decimal places. Whereas this number here only has 1. So when we add these together, we only keep the 1 decimal place. Because we only know 254.2 to 1 decimal place, we only get to keep that 1 decimal place, and we're just going to essentially get the same number. This was effectively like adding 0, because we don't know the 254.2 to enough precision that it meaningfully changes it if we add something that's 5 orders of magnitude smaller. Right, so this is like an extreme version of this rule. Okay, so let's look over the addition and subtraction. That's the addition and subtraction. Multiplication and division rules. This one's a little bit easier to remember. So with multiplication and division, the rule is that the number of Sig Figs in the answer is the same, or I should say is equal to, the number with the least number of significant figures. Okay, so again, let's look at an example. 325 times 2.5. I can put this into my calculator. We get 812.5. Now this number has 3 Sig Figs. This number has 2 Sig Figs. So ultimately our answer should only have 2 Sig Figs, since that's the least. So we have to round this. So we'll round this to just 810. Only 2 sig figs. All right. For more complicated things like logarithms and anti-logarithms, they're in your textbook. We won't really ever use them in this class very much. So those are the rules regarding multiplication division. We'll do some examples in class, and you'll also, of course, be applying this throughout your time in analytical chemistry.